So I would request you to kindly install these packages, MAS, MDA, and KLAR. And what we'll do, we will do 2 to 3 things today. First, yesterday, if you remember, we have discussed about LDA and how the LDA programming goes. What are the statistics and mathematics behind the LDA? And today we will see how we can program LDA in R. And apart from LDA, I will also, if you remember yesterday, I have discussed about various other discriminant analysis functions like QDA, FDA, and MDA. I will quickly show you how you can program those also. Please confirm once you have downloaded the data and everything. So now I can see from our group, 6 people are available, 2 more are yet to go. Iftikhar, I can see. So let's start. First, we are loading the libraries. Just let me clear my environment variables once. Then for this, we will use a data set to understand LDA. And the data set is you can say it is something like a ABCD or grammar of our machine learning. And that data set is known as IRIS. IRIS is a data set that is about various flowers and their characteristics. So first, let us load the data. Then we are creating our training and test data. So you can see what are the components that is there. So
sir, please wait for a while. Actually, the libraries are loading.
okay, sure. So meanwhile, I can actually show you about IRIS datasets. So basically, IRIS is a dataset. It is available under UCI machine learning repository, and this actually shows 3 different flower species: Iris of versicolor, Iris setosa, and Iris virginica. It's one of the elegant dataset, and it is almost like the ABCD of the machine learning, because starting our journey of machine learning, we use these datasets for multiple things: to understand, to do exploratory data analysis, to perform various analysis. We use this dataset. And as you can see, these datasets provide you various variables like or features like sepal length, sepal width, petal length, and petal width. And based on that, actually, the which species of flower it belongs to, that is decided. Either it is a setosa, or it's a versicolor, or it's a virginica species. You can see top, these 3 things are there. So this is not the major project what we'll do. I'm just trying to give a quick overview how the LDA programming goes, and then using this knowledge, we'll go forward and we will apply it into our project, which is designated, that is project 4 today, which is again on wine data, another classic dataset of machine learning. Meanwhile, who all has downloaded it, please confirm. Please unmute and confirm.
Yeah, I'm done.
मैंने थोड़ी देर में
Okay,
मैंने
so
लेट ज्वाइन किया और क्या डाउनलोड करना है मुझे नहीं पता.
okay, I mean, for downloading, I have already given you the link, so you can actually go to the drive and you can download this project 4. In our WhatsApp group, I have given the chat today morning, not morning,
Yes,
I
sir.
think late afternoon.
Yes, sir.
Okay, so there also I have given you this file, DA functions. You can open the DA function, means download the whole data, the whole thing, and open the DA functions. Okay. So I have only got confirmation from Mahendra.
Sir, I have also done it.
And then I will request you to quickly install this libraries, that is tidyverse. We have already pre-installed. Caret is also pre-installed. I will request you to install these 3 libraries: MAS, MDA, and CLAR. You can do it together. You can go to the packages. I'm not doing it because it's already installed. You can write like this. You don't have to do it, install it one by one. Only thing, guys, we have a very short time available today, 2 hours. So we have a lot of things to do. So I'll request you to be a bit quicker and faster. So please keep on responding. Once it is done, we can move forward.
Yes, I have downloaded data and now I'm creating the partition.
Okay. Thanks, Mahendra. What about Iftikhar?
Yes, sir. I've downloaded it.
Okay. And Shilpi, Babita, Achal?
Sir, I'm done with the partition part.
Okay. I think Babita
Very
was
good.
late.
I downloaded it. Yes, sir.
Yes, partition is also done.
Great. So Mahendra, what you can see, you can also talk about it. So you can see in our data, we have various features, correct? Yesterday we have actually talked about discriminant analysis is a dimensional reduction technique, correct? So we can see there, although this is a very small data and with minimum dimensionality, but we still have to reduce to identify our target, that is, it will belong to which species, correct? You can see
Okay.
that. So next, what we will do, basically, we are going to normalize the data. The categorical variables are going to get ignored. So for that, what we are going to do, so you can see what are the parameters that has got ignored. So that is the reason I have printed this. Then I am going for a quick transformation of the data. And I have created a transform version of our test and train data. Now, to run or create a LDA model under this package mass, there is a LDA function. We are going to write the LDA function, and it's a very simple function. You can see here, and it is very similar to our learning of previous regression models. So we are going to create a model LDA, and we are trying to our predictor variable here is species. So versus species, we are taking all the parameters. Okay, and we are taking the training data, and we are creating our first model. So everybody has got this model.
Yes, model is done.
Awesome. So now let us plot the model and try to see. It's giving us two LDA parameters, and it's in a 2x2 matrix. Yesterday we talked about the dimensional reduction in X and Y. Now you can see here it is showing a spread of the species. You can see Setosa is creating a very different, that means the phase separation from all other species, Setosa is very different. Whereas we can still see there is a bit partial overlap between versicolor and virginica. Is it visible? Have you got the plot?
Yes, but can you just tell me what is the line to plot this?
Okay, sorry. Okay,
Plot model.
so we are taking, means we are trying to plot, and under this column we are taking this species as integer. So basically it will take the count of those species names. Okay.
Okay.
And now we are going to print the model, and from there also we can see we are getting. So right now this is small data, so you can see basically the from our data the probabilities of each groups is coming around 33%. And but this going forward, when we'll do a real case study, we'll see this will differ, and I will try to explain you in a much more way. I'm just trying to show how this LDA basically programming works. Then when we'll do the project 4, I will explain you in details. We'll do much more in detailed exploratory data analysis to approach this. Okay, so now we have already got our model using the trained data. So let us try to go for a prediction. Okay. And now we have run our prediction, and let us try to test our model accuracy. Although here we are seeing a very high level of accuracy, 100%. But at the same time, we don't have to be very happy about it, because it's a very small data set. And you can understand, means in a small data set when the learning has happened, although it's giving a very high level of accuracy, but that also could mean that the model is a bit overfitted model. But nonetheless, we have actually created our first LDA model by using this method. So now, what are the prior probabilities of the groups? The proportion of the training observations in each group basically shows the prior probabilities. For example, there are totally 31% of the training observation in the Setosa group. What a group means, these are the things we have to always remember, because yesterday we are actually trying to talk about two things. One is basically the difference between two centroids, and that is the reason we have to understand about the means of each group, and that has to be very distinct and far from each other, and within the group the variance has to be minimal. We also understand that now. Now we have to understand about the coefficient of linear discriminants. Basically, if you try to understand how the equation goes, yesterday we have also talked about the equation. The equation is more like this for LDA1. Basically, these are the discriminator functions, and similarly LDA2 is these are the discriminator functions. And this is the way the prediction works, and we can actually do probably a bit anatomy dissection of the various predictions. What are the components we are getting under that? We are getting the prediction classes, which is providing us the name of the class we are trying to identify. Similarly, we can print the posterior probabilities using the prediction of posterior, and similarly we can actually get, if you want to get the discriminant values, you can get it using this. Now we will try to load LDA, and we will try to see how this phase separation is working out. Plot was working right now. Plot. So now you can see that with the prediction, there is definitely a clear phase separation. And we have also seen when we are working with the training data, the phase separation with Setosa was always much more clearer. But here you can see also there is comparative better phase separation has happened between versicolor and virginica using LDA also. So have you got this till now?
Yes.
Thanks, Mahendra. Any others? So shall we move forward? And again, means we are seeing basically our prediction accuracy of 100%, but that is, we have already talked about it. So now for quickly, means in other model, how you can actually create much more, means every model we have talked about hyperparameter tuning. So even in this case also, the probability cutoff is basically going to be 0.05 we have taken by random guessing, but you can actually change this posterior probabilities into various different numbers that I will suggest you to go and do by yourself, and you will be able to see a different values. So in some situations you may want to use the precision of the model. In that case, you can model the fine tune by changing the posterior probability cutoff. So you may increase or lower the cutoff values, and you can see the various varying level of model accuracy. Now yesterday we have, so that was about LDA. Now quickly I will show, because these are not part of our major agenda of the day, but I wanted to show it to you. So the thing is, yesterday we have talked about various other models of discriminant analysis, like quadratic discriminant analysis. So this goes into the same way using mass, and here instead of LDA you are going to write QDA, and you will get a QDA model. So here you can see the QDA predictions, although in all the cases we will get almost, because it's a very small data, we'll get accuracy, very high level of accuracy, but this accuracy values will definitely change when you are working with some other data sets. So that is the way you can basically get your QDA. Now if you want to write a mixture discriminant analysis, on that I have also given you one article to read in our group. So if you try to read and understand that, I'm just opening it for you quickly. If some of you are more interested to understand about the differences of various discriminant model, I'll recommend you to go and read this article. It's a very detailed article, and especially here they have shown how the phase separation happens in 3 different methods. The author has used LDA apart from the mathematical expression of MDA, LDA. He has also given a detailed example. So for the example, you can see with this data, the decision boundaries happens in LDA in this way. So there may not be very clear phase separations in some of the cases. So QDA can give you this type of phase separations, and ultimately if you are using MDA, you can see it will give you much more clearer separations. So I will recommend you to take out some time and read that. And to write basically MDA, you have to use that library package I have mentioned above, because that is not available under MAS. So that you can get from library MDA. And if we run a MDA model on our same data, we can get our MDA predictions. Similarly, if we try to compute flexible discriminant analysis, that is FDA, we can get it using again MDA package. And instead of MDA, basically you have to write here FDA, and the prediction goes into similar way. And if you want to write or compute regularized discriminant analysis, then this is the technique. And for that, you have to use that CLAR package. And you can see here the accuracy, it is giving 93.33%. That overfitting thing what I was talking about, that it is not actually coming over here. So in this case, RD is comparatively, as per my understanding, it is giving better prediction. So that is all about how we write various discriminant analysis functions. Till now we are good?
Yeah, I think we are good with this, but if I compare it with the logistic regression, then if I do
I
the
know
same,
that. I know that. That
Yeah.
question will come from you. So that is the reason I have actually kept another example for you. Good. Thank you for asking that. So if we get a time, I have actually done another example to show you. And so could you do it quickly? Then in that case, we can do this one also. And here, basically compare to a logistic regression model, how is the prediction going in LDA that we have done. So you want to do that, but quickly, because we have to complete the project 4. Because this basic understanding of the programming, because that will take at least good 2 hours of work. So that's why I'm suggesting. Or you want me to share this with you and then discuss separately?
Yeah, I don't think that preparing a GLM model here and then talking on it will be a better option, because we have limited time. We'll do it separately. I'll do it at my end, and if I have any questions, then I'll ask you.
Yeah, and exactly the same means the same way. I will probably quickly share this DA tutorial what I was prepared for you, or at the end of the class, if you get some time, we'll come back to this. Is that good?
Yep.
Because there we'll be able to see.
Share these codes also, please.
Yeah, absolutely. Means already DA functions and project 4 part of the codes are shared with you, and this DA tutorial also I will share with you. So now let's start with our major agenda of the day. Let me clear my environment variables. But you understand clearly one thing, what functions you are going to write for LDA, correct? And you understood about the mass package, and at the same time to understand more about the mass, I already have discussed with you how to look into various package and package functions. So especially for these 3 packages, I request you to go to their vignettes and to understand about the various functions that is written under there, to understand it clearly. If you have any doubt, you can ask me in chat.
Okay.
So good. And I'm only getting response from Mahendra and Shilpi today. What about others? Babita, Anchal, Iftikhar, we are all good?
Yes,
Shall we
sir.
start
We are
with
good.
project? So meanwhile, have you downloaded the project 4 data? So project 4 data is basically a wine quality data. I think some of you have already looked into various different wine quality data, so you understand a bit about the wine classification. So it's one of such data, and this data set is basically having various variables. So let us open the data also quickly to understand the dimensions of it. So interestingly, this data is basically a TXT data, and the headers are given separately. So what you have to do over here, you have to join the headers. So that activity we will start doing in our R. So before that, as a standard practice, we will create our libraries. Some of you do not set up your libraries. Please do that. And here the libraries we are going to load are the following. I'm quickly keeping it wide for you so that you can do it together. So we'll load ggplot, dplyr, ggpower, ggle. These are for visualization, tidyverse, again for data wrangling and visualization, wrapper, scales, basic, mass, clar, caret, and reader. Please let me know once it is done. Everybody is through setting up their libraries as well as setting up the working directory. I'm just waiting for 2-3 minutes for this, because all these libraries are now available with you, correct? No new libraries, or you have to install anything. I'm also sharing this. You're done? I'm also sharing this code snippet with you for quick processing. If anybody is, but please do not just blindly copy paste. Please set your own working directory. Now let us load the data, and as we know, it's a txt file.
Hello, sir.
Mm-hmm.
So just wait for a while, please.
Okay, sure. So where you are facing challenge? Shilpi, exactly which step you are facing the challenge? May I know?
मेरा mic ही नहीं चालू हो रहा है. Hello, sir.
You are very much. Don't get panicked. You are very much audible. We all can hear you. We will wait 2 more minutes for you. Don't worry. Meanwhile, some of you can actually at least what you can do. You can load the data. And write this code snippet. Meanwhile, we'll wait for Shilpi, because you can actually start looking into the. And please, here from this part till you will basically use your path. If you are finding any difficulties to load, you can also use the import dataset reader function.
वाइन डेटा वाइट लेना है, वाइट वाइन डेटा लेना है कि रेड?
So actually that is a separate data. So it is not the white wine data or the red wine data. It's very similar to this only. Basically, it's a mixed data. Okay, so take this data.
Okay.
I think you have already downloaded the data from here, correct? If you have
Yes,
downloaded
sir.
the project 4, so there is a txt file of that. Actually, this same data is also available under. You remember I have spoken with you about a package by name Rattle.
Yes, sir.
In I have shown it
Yes,
to
sir.
you how it's a GUI based analysis where you can actually use various regression decision trees and all those analysis within R. So Rattle has got this data, and if you can load library of Rattle data, you will get the same data. But for our standardization purpose, let us not take the data from there. Let us take the project data which has been given to us. Okay.
Yes, sir.
And these are because you can see this is a data that is given in a txt format. Okay, and there are no headings, so you have to actually add the header separately, because that is a one thing. It's a good thing, because many times you will get data and data mapping file or metadata file separately. So now this will also help you to understand how to manipulate such scenarios. So go with this. Okay.
Yes, sir.
So Shilpi, are you good? Are we good? Hello. Achal, Iftikhar, they're good?
Yes, sir. Yes, sir.
Yes, sir.
So let me also load the data then. So I have loaded the data, but now you can see, if I just load the data, it will come like this. There are no headers. There are only values of various variables, and first is a parameter which is going to be our target variable. So let me also put the header into the data. Yes. Now I have also added the column names, so you can see my data is coming like this. So it is actually talking about, and meanwhile probably Shilpi is loading. So Mahinder, how many variables we are seeing, how many features we are seeing in this data? Because type is our target variable. Apart from it, how many variables we are seeing here? Just for a quick understanding. One, two, three,
Total
4, 5, 6, 7, 8. Total 13, correct? These are our various features in the data. Correct?
Yes.
And these are the features are basically we are going to do a dimension reduction on these features to get the which type it should belong. That will be our predictor variable. Got the logic?
Yes.
That you can actually find it out from here also, because there are 177 observation of 14 variables. Okay. So on that note, what is the status of everyone? The data has been loaded. We have looked into the data. Shilpi, you are not audible. Means I am asking you a question. I think you in between you have got panicked. Have you got the data? Hello.
Now I am audible.
Yeah, you are audible. You're clearly audible.
Hello.
You are clearly audible. You are clearly audible. Okay. So we can proceed forward and then we'll come back. Okay. So after loading the data, what we do next? Next step, class, what we do once we load the data?
EDA.
And in this particular scenario, from our yesterday's understanding, with EDA, what are the other things also we have to check here very carefully?
With EDA,
Means with, apart from the, definitely we'll do the EDA, but with EDA, what other things, what other attributes we have to check very carefully in the data? Yesterday we have talked about
distribution, is it normal or not?
normal or not, because thank you, very good answer, Mahendra. Because yesterday we have discussed very clearly, to justify the LDA, it has to be normally distributed, correct? So these are our various 13 parameters and their values. We can create a quick summary. Similarly, we can see what are the structure characteristics of this data, and all are there numerical. And is there any NA? So we can see there is no missing data that is presented over here, correct? Now we have to basically understand the target attribute. So what is the target attribute over here?
Type.
Which is a target type. Thank you. The type is basically the target attribute. Thanks a lot. So we have to see what is the distribution, and we can actually find it out, the various distributions of it through a bar chart. We can actually create a quick so we can see in our data basically, and this we are doing, if you remember, when we have yesterday talked about the LDA, we have also talked about the various class distribution and their balances. So you can see this is comparatively balanced data, correct? So out of this 177, we can see the highest numbers are although coming from type 2, but it is also very closely followed by type 1 and then basically followed by type 3.
Yes.
Correct?
Yep.
Now what we'll do, because we will try write basically a small function, and that function, with all these parameters, we will try to create the histograms, and then we will actually plot it one by one. So this is a bit complex code. So what I will suggest to you, you can actually take this code and run. You have got that function. Within that function, we are actually building a lot many plots, and then one by one variable we are going to check it. So please run this function. If you want, I am not just going into the details of this function because that will take a lot of time of ours. We can, so that time we can effectively use in our understanding of LDA part. But if you have any other problem regarding this function or understanding, you can ping to me separately. Meanwhile, just run this function and please let me know if you are getting any error.
No error, but it's not plotting.
No, this will not plot now. Next it will plot. We have actually created a function of this plot. So now it will start plotting from next.
Okay.
We have created, this is a function which is going to take out multiple graphs together. See, basically in this, I'm just talking very theoretically to you, means, or probably let me plot one of the graphs and then I will actually talk about it. So first I have taken a parameter and it's loading. You will see a very elegant plot now. It will take a bit time to load. So now you can see this function is actually taking out multiple plots and it is aggregating together. So one of the plot is giving a box and whisker plot. So we understand why the box and whisker plot is used.
Yes.
Anybody remember? To check the distribution and outlier in the data, and we can
Yes.
see what is the distance from the mean using that, and we'll be able to also identify outliers. Apart from it, you can see this is the alcohol data, this is the logged in transform of outlier data. Just give me, hold on for 1 minute, I'm actually getting an urgent call. Meanwhile, just try to write this. No problem, that call has got disconnected anyway. So, and these are the various transform version of the data to see and check the distribution. So from this, what we can draw, well, how this data is distributed. So we can see alcohol, there is no outlier present, and the distribution also, it's almost normally distributed, and with transformations, log transformations, we can see the distribution is also showing a proper normal distribution. Are you correct?
Yes.
So now let us run it for. So that was basically for the first variable, that was alcohol. So similar way, now let us run it for malic acid, the next variable. The similar way, you can just quickly keep on changing, as you have already written a loop function. Now you can actually go and check similar way the distribution of all of your parameters. I'm quickly running them. Meanwhile, you can actually write them. It will take some time to run. Meanwhile, So we have got the plots.
Yes.
So from your understanding, which all has got some outliers and which all has got some distribution problems? So this was for alcohol. We have looked into it. Next, if you look into malic acid, what is happening? Oh, it is not plotting. So in ash, oh, I think it is it's a loop function and it's taking much more time to run. So you can see in ash basically there are, you can see there are two outliers, although, but with the distribution still it is falling still within the normal distribution, and with transformations also it is still falling within the normal distribution. So now let's go into alkalinity. You all are able to print it, because in my system it is responding very slow. I think I should keep.
Yeah, for me all graphs has been printed.
Means in my system probably I need to give some RAM to my system. So everyone can get the graphs for understanding. Apart from Mahindra, others please respond.
No, sir. It is taking time.
Okay. Machal,
No, sir, it's still looking.
Gopal, I can share all the graphs, a screenshot of all the graphs on WhatsApp group if you want.
okay. Or yeah, I think they will be able to run it also. Means if they are not able to run, so basically this to understand about three things. So let me talk about it. To basically understand how what is the data distribution, is there any outlier or not, and if means if is it normally distributed, or is there a requirement for transformation. That's it. So probably we can move forward, because I have shared the code with you, so you can sit on you can also understand about try to understand the principles behind it. And if you are finding any difficult, because this will take long time, I understand, even in my system also it is taking long time, but some of the important plots let us run. So we are now going to do the bivariate analysis, and
No,
here
Gopal, one thing one thing, proline plot for proline is, I think, right skewed. But if I look at the plot which is for how would I say it, with log value, yes, with log value it is showing as normal distributed, but without log it's right skewed.
Proline. Okay. So I think in that case, what you can also do in such scenarios. So why to give this idea? So in that case, probably when you are loading the variable, right now we will do the LDA with all the variables, but proline, if it is showing going forward, we will see if there is a important prediction of proline or not. If it is not there, or if it is there, in that case it will be recommended to use a log transformed proline version than the proline original. Got it? Yeah, we can see you are correct. You are correct. But with log transformation also, it is not the distribution. Yes, the log 10 transformation we can actually go for. Yes, we can go for a log transformation. And let us try to run this correlation matrix. Why it is, what is problem? Yes. So we can see here, as you're talking about proline, but proline is, let me save it and see. Is proline contributing in type classification? May not be much. Mahendra, I think proline is not contributing much in basically in type finding, because right now we can see 3 are showing. One is a malic, alkalinity, and then non-flavonoids, not the proline. So that could be also a reason. You see what you are telling, because of the data anomaly could also be the reason. So what I can suggest to you, you can run a log function, log transformation on the proline data, and you can run this correlation matrix to see if it is coming, because we can actually see a correlation between basically malic, alkalinity, phenols, flavonoids, hue, dilution, and proline. But with proline, that is not. That is a, okay, it is 0.6, but in a downhill. So this is 0.8 in downhill. Okay, 0.8 in downhill. So there is a negative correlation with proline and type, but we can actually do a transformation and we can see what you are suggesting, that is showing much more stronger relationship, or the relationship is coming down or not. So that was your suggestion, correct, Mahendra? Hello.
Yep, got it.
So you can create this correlation matrix by yourself. I've just given the code to you. So now we can see some of the variables are basically relevant on target variables, and there are some variables which are basically showing correlation between the other variables as well. So here in this case, we have also talked about autocorrelation, which we need to look into, and autocorrelation is one area we will try to avoid. So in that case, this correlation matrix is a very useful insight for us.
Upal, sorry to disturb.
Yes.
Perhaps Shilpi wanted to ask a question and she is not audible due to some mic problem she is facing.
Okay, what she is telling?
Her question is that she wanted you to please forward the code so far in one go. कहीं एक जगह ही copy paste करके आप या तो mail पे डाल दीजिए या और समझे.
Okay, just 1 minute. Let us wait for Shilpi.
Shilpi, am I audible to you? Kindly respond, yes or no? Maybe in chat. That will do. Okay, but yet you are not able to use the mic. Mic में अभी भी problem कर रहा है. Okay, Shilpi, I would say, what do I say? Please bear it for now, and check it. Check your headphone properly after the session, and I hope it is problem at your end because everybody else is perfectly audible and they can listen to Upal also. So no problem. Drop a chat, and I will request Upal, please keep an eye on the chat box so that उनका क्वेश्चन आपको मिल जाए. वो बोल नहीं पाएगी क्योंकि पता नहीं पाएगी आपको.
I have actually pasted all the code till now in pieces. If she can scroll down, but for her anyway, I'm actually pasted it again.
Okay, very fantastic. Shilpi, here it goes. I hope it is okay now.
And meanwhile, Shilpi is looking into that. So any others from the class? So what we can see? Will you try to discuss? Meanwhile, Shilpi is coming up to the speed. So what we can see? Anybody can talk about it? This is a correlation matrix, and this is our type. That is our target variables. So what we are seeing here, from our understanding of correlation, anybody want to speak, please?
Yeah, I can see that ASH as it doesn't have any relevant input here. We can remove it, ASH, and we can remove this. I can't read the name. What is the name? Is just second.
So let us go one by one. So type and alcohol. So what is that?
Type and alcohol.
Type and alcohol. Type is our predictor variable, correct? So because this discussion actually I know probably you have also tried to look and understand this. So let us discuss. It will help for everybody, and not only Mahendra. I will also request remaining team to also talk about it, so that will clarify each other's doubt. Okay, so type and alcohol. We are seeing the alcohol is not contributing much into type determination, correct?
Right.
Although means correlation is not a causality, but we can see there that relationship is basically negative and negative weak relationship, correct? Now,
yes.
What about type and malic?
We have correlation, positive correlation there.
we have a positive partially aphil relationship. Okay, not very strong, but aphil, because you remember we have actually shared those values to interpret.
Yes.
Yes, sir.
And next, ash. You
No.
are trying to talk about ash.
We can remove it.
We can actually remove it. Even ash,
Yeah.
we can see we're not showing much, except with alkalinity. Ash is also not showing a relationship with any others. Much
Any other.
relationship. So we can actually see if there is because ash and alkalinity, we can see basically there is a positive correlation. So if here
Yes.
and alkalinity is also contributing into type.
So we can keep alkalinity, but we can remove the ash.
We can remove the ash. And so now I will request any other from the class to talk about it. The way Mahendra was trying
Sir,
to
we can
explain.
remove also magnesium.
Mm-hmm.
We can remove
And
also magnesium.
at the same time, we can also remove magnesium, because magnesium, we can see there is a weak correlation with type. Weak, that is a weak negative correlation with type, and it has got a basically relationship with proline. So we cannot remove proline. Okay, now phenol.
No, sir, we can't remove phenol.
Because phenol has got a
There is a
Strong negative.
strong relation.
strong negative. Awesome. So what about flavonoids?
Strong negative.
No, sir, strong
We
negative correlation.
cannot remove it here.
We cannot remove it. Then non-flavonoids.
Cannot.
Cannot.
Okay. Then proanthocyanins. We have
No,
to keep
can't
it.
remove. We have to keep it.
Then color.
Color. Actually, it is contributing with HUEU, and the last one I can't read
Hue
the
and
name.
dilution. Hue and dilution. Dilution. That is dilution.
So it's contributing with that. It has collinearity with that, correlation with that actually.
So if we are keeping hue and dilution, and we can see there is a both hue and dilution has got a
Strong.
negative.
If we are
Strong.
keeping these two, then we can remove color.
Dilution is basically stronger, and hue. If you are keeping hue, then color is not required.
Yes.
Hue is basically when you look into take an alcohol and look through it, the color you get it, that is a hue. Because you might have seen, for example, rose wine color is very distinct. It has got a very distinct hue than red wine. Now you got the concept of hue.
Yes. So here we are keeping hue and dilution, and we are removing color.
A color we don't have to take.
Yes. But we are keeping proline as well.
We are keeping proline as well, as it has got a negative. And probably one small thing, as we are also going to work in this at home, so we will do a log transformation of proline and see if this from 0.6 it is going up with a log transformation or not, what you were suggesting. Okay, so that is the thing we'll do at home. So Shilpi, are you good? Have you reached till this point? You can write in the chat. So you have reached. Okay, great. Thank you. So you are able to run till this point? You have understood what we have discussed? You can just type yes. Okay, great. Awesome. So what I will do parallelly, I will keep on looking into the chat as you are not able to speak. So, and all others are good? Those who has not spoken?
Yes, sir.
Iptika,
Yes, sir.
Achal,
Yes.
Yes, sir.
we are getting till this point, correct? Now, I'm just sharing this next part of the code with you, then I will just run it. the similar way, we are actually going to run the plot, bivariate plots with all of them. So you have got the code snippet. I'll just go and start running it. And here we are just selecting the variables we have actually talked about. And then we are actually trying to create a GG pair plot to see how they are contributing.
This plot is heavy, it will take time.
Yeah, it will take time. That's why. That's why I have stopped over here. Because it's not a single plot. It is plotting multiple plots at the same time.
Yes.
Thank you, Mahendra, and for your contribution and talking, because then it sounds like I'm still sitting in an interactive class and someone is trying to understand. So I will also encourage if you have any insights and any thoughts you can share, which is definitely relevant to the project, and freely ask your questions. So that plot has come, and it's so you can see here the same correlation we can actually plot vis-a-vis type, and here we can also see their distribution, like Malik
Right skewed.
right skewed, alkalinity almost
It's okay.
normal,
Almost normal. Yeah.
phenols,
This is also
flavonoids,
but it's okay.
it's okay.
That's true.
Non-flavonoids is also normal, and
Almost
procin is also normal. Hue is also normal. Dilution, there are 2 humps, but almost normal. And proline is basically, as we have identified before, it is
yes.
a bit of
Right.
right skewed. So it's helpful till now. So let us go. And it's also showing basically 0.541% of positive alkalinity attributes in correlation with target attributes. So alkalinity is basically one important parameter. So let us try to create a bivariate plot of alkalinity and the type and see. You can see here one interesting thing is basically alkalinity, the values are contributing basically when the levels are below, they are contributing much more into the class of type 1 of alcohol. And
Yes.
you can also see a clear phase separation that is coming into phase 3 when the values are basically above I think it will be around 18 or probably 20. But type 2 is basically having a mixture of alkalinity, and you can see there are some outliers are also coming. The most clear relationship we can see with basically with type 3, correct?
No, yes, some confusing. Can you repeat?
Okay, so now here you can see if the basically alkalinity values are below, means we know how to read the box and whisker plot. So if
Yes.
the values is in and around below 20, you can say clearly, then in that case their alkalinity values are basically contributing to the class of type 1.
Yes.
And if it is more than 20, it is contributing much more into the type
3.
However, in type 2 we can see there is a mixture of values, correct? It's a means if you see the range of alkalinity and try to draw a relationship with type, we can see a comparative pattern with alkalinity, and we can see it with type 1
Yes.
very clearly, and we can also see type 3 and alkalinity. There is also a pattern, but in type 2 it is basically coming more into a not
Both
very clearly.
Yeah, not
Yes,
very clear.
please go. No, please go ahead. Yeah, it's not very clear, and it is a mixture of the thing. So the same thing I have also tried to capture it for you. So you can notice if the alkalinity level is below 16, the wine might belongs to the type 1 or type 2. However, some range of alkalinity is overlapping with each other in the case of type 2, and in type 3 it's actually giving a comparative clear phase separation where it is above 20. Now let us go into the next parameter and the relationship with the predictor. Still now you can see that we have not gone into the model building, because model building here we understand it's a very single step method, correct? But in that case, in LDA, what we understood, what is very important for us? Anybody in the class?
Checking the, first of all, distribution.
Checking the distribution pattern, their relationship towards the predictor, because then only that particular phase separation among the values, and it will actually contribute towards the type finding. Are we getting it?
Yes.
Yes, sir.
Now let us run in Malik. In Malik, what we can see now, we have already discussed about that. So anybody from the class, they will try to decode this.
Yeah, that's we can clearly see for that for type 3 classification is good, but for the Malik
So
is
basically for type 3 alcohol, the Malik values are higher
higher.
than others. It's very clearly visible. Okay.
Yes.
One,
But for
we can
type 1, type 2, no, it's overlapping.
and type 1 and type 2 is basically a bit overlapping, and where we can actually see there are some outliers are also come. The range basically for type 1 is very narrow, type 2 it is wide, and we can see there are some outliers that is also coming in pertaining to the Malik parameters in type 1 and type 2, correct?
Yeah. Yes.
So what we can understand, Malik is not going to be a very clear-cut predictor of type. Now I'm actually trying to talk why you are doing this. If you are only using Malik in our model building, it will not be able to give a clear-cut prediction of the classes. We can see that.
Yes.
Except 3, where it will give a partial finding. So the same thing I have also taken it down for you. So you can see the Malik values for type 1 and type 2 classes are overlapping, and it might correlates with other attributes. And type 3 contains Malik acid values higher than others. And we cannot decide the type of wine based on malic acid values very easily. So let us go into our other parameter like non-flavonoid and see. So I will here specifically, not you Mahendra, probably out of any other students in the class, will you try to what we are seeing here? If you want, I can actually make this graph bigger. Shall I? Is it better?
Yes.
So what we can see here?
Can I?
No, means you will definitely come, but I don't know why others are so silent today. I understand because you have got the logic very clearly, but I also want others to get the logic, or else you will give the answer. I will give 1 minute for the class. Somebody please answer. Else probably Mahendra is a person to go to person. Or shall I name call? What about Achal or Babita? Because Shilpi is anyway not audible. Or Iptikar, will you give a try?
Can't,
Yes,
sir.
pardon me? Hello?
Hello.
Okay, so probably let me ask very specific with specific names. What about Anchal? Anchal, you want to give a try? What we are seeing here?
So basically, this parameter is contributing more in type 2.
But type at the same time, type 2, the range is very wide, correct?
Yes,
So
and for
Type 3.
type
then
1,
how? Go ahead.
but in type 1, it's covering the range is low, but it's covering a lot of.
So
I,
Uppal, but I don't think that here this
that is the right
non-flavor,
answer.
it is not helping us classifying because
But type 3.
everything is overlapping.
So there will be still overlaps, but you can see, at least you can see the non-flavonoids values. If it is lower values, they
Yeah,
are contributing much into type 1. If it is a higher values, it's contributing and going and contributing to class 3
type 3. But
and
still,
type 2.
lot of overlapping there.
Yes,
If you look at
absolutely.
the hinge coverage by hinge, then it is overlapping for all three type 1, 2, 3.
So I absolutely agree with you because this non-flavonoids alone will not be a very good predictor of type. So that is
Yes.
also going to be the findings. But at the same time, we can see a minimal phase separation in the case of 1 and 2, and 1 and 3, not with too much because 2 has got again a range of, that is a wide range. So that is the same thing I have also captured over here, that we can notice that level 1 type is the low, and that is the only take we can take. Basically, if the values are low, then in that case probably it will classify within basically type 1. That's it. Not much help, as you have rightly said. So now let us take the flavonoids. It is just other way around. It's almost an inverse of
Yeah.
inverse of the non-flavonoids, correct?
Yes.
So we can say where the flavonoid values are low, that will become to the class 3. Where it is
3.
high, it will go into class
Plus
1.
1.
And compared to now, if you see, remember our previous graph of non-flavonoids versus flavonoids, you can see here compared to non-flavonoids, the phase separation is comparatively better, correct? Although in 2 we can see there are very high outlier values, but comparatively we can see a better phase separation here.
Yes.
So the same thing I have actually captured also. Now let us try to find out the correlation between 2 parameters, flavonoid versus dilution. What we are seeing here. So there is definitely a correlation, and there is a potential multicollinearity
Yes.
that is existing over here, because we can see the aggregation of the values. Although it's not a very linear relationship, but there is a relationship that we can see. The same thing, these 2 attributes are correlated highly, and when the value of the flavonoid is basically low, then in that case the value of the dilution is also low. And while the value of the flavonoid attribution might be high, in that case the dilution attribute can also be high. And now we will check how these 2 attributes correlates with the effect of wine type. So just ignore 1.5 over here and 2.5 over here. Take 1 and 1, 2 and 3. Okay, and you can see is there a pattern? When it is basically high flavonoids and high dilution, there is a more chance to fall under the class 1. And when the flavonoids are low and dilution is also low, it has got a much more chance to fall under the class 3.
Right.
Correct?
Yes.
So that is a way we can actually do our anatomical dissection of our data with proper EDA by looking in before just we build a model. Okay, so that is the reason. And now with this EDA, what we can find it out, we can basically identify how 2 attributes are correlated with either each other or our predictor variables, or we can also identify basically which is going to be a better contributor in the model development. So on that note, shall we start the model development? And what I will do, I'm going to quickly share this code snippet to you also till the end, because we have half an hour left. We should use it very, very effectively. I have actually also started writing a QDA model on this data. I have not completed it, so I will request you, if you take out some time and basically run QDA, FDA, and all other type of discriminant analysis also with this data, and various version of LDA with partial selection of the data. I think we can take that out as one of the homework for us. How about it, guys?
Okay.
Will it be helpful? So now let's start. Basically, now first, till this point, this variable, we have seen the structure. It was coming numerical, correct? Type.
Yeah.
But to do LDA, what we have to convert? We have to convert the data into
Vector.
Absolutely. Thank you. So you have done that conversion. Then we have created our training data and testing data out of it. Is it done? I'll wait for some time so that all of you are up to the mark. And I think our training data and test data is ready. Everybody?
Yes, for me it's done.
Sir,
Others?
done.
Shilpi?
Done, sir.
Okay, Shilpi has also confirmed. Okay, Achal has also confirmed. Great. So we'll move forward. We'll build our model, and the model name is LDA wine. So with this LDA wine, we can actually have got our LDA wine. This is our model. And now, sorry, I think.
It's LDA.wine.
Yes. Then I have to just hold on for a moment. I have to do a quick check, and I will just reshare the code to you. Sorry, I think this was wine LDA values. Okay. Yes. So I think
Okay,
there is one line. Just yes. So I think just this line need to be corrected. So this LDA wine need to be just corrected. Any problem? I think I heard Bobita.
No, sir. It's a मेरी टैप वाली लाइन में एरर आ रहा है टेक्स्ट लाइन वाली में टाइप
Which
ऑब्जेक्ट
one?
नॉट फाउंड सर ये टेक्स्ट वाइन डॉट एलडीए वैल्यू सर आपका रन कर रहा है मेरा टाइप में एरर आ रहा है यहाँ पे टाइप ऑब्जेक्ट इज नॉट फाउंड
एक minute, just let me check it. Where you are getting the error? Are you able to get this plot?
Which one? Yes, sir.
This is basically just formatting of that plot only. So you are getting the plot, correct?
Yes, sir.
And this provides the.
While I'm running this line, that this one type is the code says error in a type. There is no object is type.
Okay. But in your data there is a type, correct? Oh, okay, got it. Do one thing. In that case,
Okay, then
you just
LDA.
put a dollar. Put a dollar, means take the data frame, put a dollar, and just check.
Okay.
It's the same attach type of problem.
Yes, sir, I got it.
Got it? Sure.
Yes, sir.
Okay. Everybody, you have got it? So we can see across two LDA planes, there are separation of data.
बच्चे क्लास में कंप्लीट करके सबमिट करना है.
And now if you try to create a data from I think my new data it is not taking type again. Perfect. So now we can see with the our model is basically separating across the plane. You can see the clear separation of three types: type 1, type 2, and type 3. Is that coming? So now from our data, earlier we have talked about the prior probabilities. So this model is showing the prior probabilities is basically, so just let me write the model. Where is our model? Print the model. So have you print the model? So now you can see the how much the prior probabilities for these three groups are coming. For group 1, it is coming 32.76%. So that means in out of training observation, basically 32.76% is falling under the class 1, 40.11%, sorry, it should be percent of the training observations are 1 year belonging to class 2, and 27.11 are basically falling under the class 3. Similarly, we also need to understand about the group means of various predictors or various contributors to this. So in that case, we can also understand. So these are going to be the group means, which is falling under 1, 2, and 3. And LDA1 basically is a combination of 13 predictors, and LDA2 is another 12 linear combination of the same 13 predictors, because we have not dropped any of the variables in this. So similarly, now what we can do at home, we can drop some of the variables, column drop, and we can see if it is providing a better outcome or not. And similarly, the stress proportion we can see with LDA, that shows the variance among the wine types. And if we try to visualize the plot, it actually shows how the training data is basically separating the various types, so which can actually helping us to classifying these wines. Now we can take the model and we can find out what is the training accuracy, and then we can go with the prediction on our test data, and we can similarly see what are the prediction values for each. We can get confusion matrix, and in here also you can see the accuracy is coming almost around 100%, because again we have to understand this is a small data. That might be the reason behind that. However, in a large data you will see a very good class accuracy with LDA, and this is basically, earlier you have seen 2x2 confusion matrix. So this is multi-class confusion matrix, and here actually you can see one more thing, that is a kappa. Kappa is one interesting thing. I also want to talk about it, kappa, because it is basically, suppose if you, kappa is basically what is, it's a qualitative parameter to look how accurate your prediction is. That means if you're taking this prediction into various people or various models to predict, what will be the overlap or common decisions to look into. Usually there is a kappa range, and if your kappa value is above 0.9, that is considered very good kappa. That means absolutely, you can see here we have got almost kappa is around 100. That is again a bit of overfitting according to me. So if you want to understand about the kappa, I will send you an article to you, but you can also understand the kappa is basically various kappa levels you can understand. That means if the kappa value is 0 to 20%, that means there is a slight agreement. It basically talks about the agreement. For example, now the same thing, if all of us in the class we are looking into, and then we are giving our own opinions, what is the level of agreement among our opinions? For example, I am probably telling it is a class 3 wine. Mahendra is talking about a class 2 wine. You again probably Bhavita is telling it's a class 2 wine. Probably Alok is talking about it's a class 3 wine. Then Achal is telling it's a class 3 wine. So you can see the most agreement what we are getting around here, and that is the value is talking about a kappa. So if you see, if multiple models or multiple people are coming into a same agreement on the outcome, then it will have a very good kappa score. And going forward, you will see the kappa values are basically very good predictors of your model. Earlier we have talked about confusion matrix, but we have not talked about kappa. So this is a new thing I'm also introducing to you. But yes, we also look into kappa. Then similarly, if the kappa score is 21 to 40%, it is known as fair agreement. It's 41 to 60%, it is known as moderate agreement. It's 61 to 80% as substantial agreement. And if it is above 90%, 81 to 90% is almost perfect. So here also it's a large range, 81 to 90, 81 to 100%. So usually in industry we take it above 85% agreement, and if it is above 90%, it's a perfect agreement, what we call as. So hope you understood the concept of kappa also.
Yeah, little bit.
Okay. Meanwhile,
So-
I can see. I think I have seen in which line. Okay. Shilpi is talking about. Shilpi has. Means I have heard Achal is asking something. Achal, please tell me. Hello.
It's not me, it's Babita.
Okay. Babita, please tell me.
About kappa.
So you wanted me to ask something, sir. I have heard sir from you.
No, sir, I'm not.
What has happened? Means hope you are getting everything clear till now.
Yeah, sir. I clearly know about the kappa. You explained it. That is not a problem for me.
Okay, so you have used kappa as a parameter before.
Yes, sir. I heard and a little bit read about it.
Okay, so kappa is
In a
basically
decision tree as well as forest tree.
actually kappa is a parameter you can use in any of the models. Any of the models, when basically if you see, there are some of the quantitative parameters and there are some qualitative parameters, correct? Like confusion matrix give you clear cut quantitative parameters and accuracies and those parameters. Similarly, kappa is one thing, it provides a quality, it talks about the qualitative level of the model. It talks about how this model could be acceptable across the group. Okay.
Yeah.
And similarly, the other things we have also discussed in details before, like true positive, true negative. And if you remember, but still I have mentioned these things for you. We also understand p values, false positive, false negative, and those parameters. So I'll request you to look into it. Hello. I have heard somebody playing. Pardon me. Hello. Anybody? Any
No,
question?
sir. No, sir.
Okay. So similar way, probably we can also write a model of QDA, and I have also shared other type of discriminant models to you, like FDA, MDA, RDA. So I want you at home just to try those model on the same data and try to see what is the outcome. At the same time, in LDA also, right now what the model what we have written, we have not exclude any features, we have done it with the whole data. So what we could do potentially is basically we can drop some of the features which we have seen during the ADA, that they have got correlations, and we can see how it is our model is outcome is improving. So in this week probably could all of you can do that and get back.
Yes, I can.
So on that note, basically we have saved some 5-10 minutes time. Probably we can take some 10 minutes extra also, and let's try to look into the other data and where we are actually trying to look into the comparative one. Shall we quickly do that?
Yes.
Yes, sir.
Yes, please. And thanks a lot for all of you. I went actually a bit quicker because I wanted to complete all the three things to you. Not only just this case study, but I also wanted to show you the various different discriminant analysis techniques and their outcomes. So thanks a lot to you for contributing in that. So now under this, shall I just till it's not, I think I have not completed it fully. I've just started writing it, but still I'm sharing it with you in the chat. So meanwhile, I think some of the libraries might not be available to you, which you have, let me clear my environmental variables because it has already become cluttered. So what I'll request to you to install some of these packages which might not be available to you, like some of are installed to me, but in your case probably you have to install this modeler, broom and ISLR. Please let me know. Please confirm in the chat when everybody is done with it. Because here we are going to use the data from ISLR. So this is a description of the data which we are going to use for that. The data name is default. And it has got basically 4 variables. One is a predictor variables, that is defaulter or not. Then it is a student or not. Then what is the balance and what is a numerical, so what is the income. So the default is basically a factor that comes with yes or no, which indicates whether the customer defaulted their date or not. And if that person who has defaulted was, that customer was a student or not. And balance is basically the average balance that customer has remaining of their credit card after making their monthly payment. And income talks about the income of that particular customer. And this is coming from the ISLR package, which is Introduction to Statistical Learning and Applications. I think some of you who has given the earlier resource I have given to you, there was a mention of ISLR package. So hope everybody has loaded this code and these packages. I will really appreciate if you just type in the chat box as yes or no, or you at least confirm verbally. I've got from one Achal. All the packages are installed. Babita, yes.
Yes, sir. I will install.
Okay, so Shilpi is basically doing it, and I think I have got a confirmation from Iptikar also. He is doing it. Mahindra, is it completed for you?
No, I think data we'll get from the ISLR library also only, right? We don't need to
Yes.
download from it somewhere.
No, you
And
don't have to. You don't have to download. We'll just directly call the data the way we have called Iris.
okay.
So that is the
And what
reason I
about,
need you to install ISLR.
okay. And from where I will get the code, or I have to write down all the codes here?
I have already pasted the code in the chat.
Okay, I didn't paste. Give me one
Sorry,
moment.
I should have told. So because of the time is short, so I have already pasted the whole code till the point I have written, and I have touched up in this code. I have touched till the point of QDR. So what I want you to complete this with QDR. I want you to write MDR and RDR, FDR type of models, and then we will compare the various outcomes of logistic regression vis-a-vis LDA, vis-a-vis QDA, vis-a-vis MDA, and what are the difference we are getting. Okay.
Okay.
And I will also upload this code for you apart from pasting over here. And meanwhile, during the course of the week, if I am progressing much on the code, I want you to also submit your codes to me, or probably if you are stuck somewhere, you can reach out to me. I will also help you in that way. Okay.
Okay.
And this basically here what we have tried to approach is basically we have created a logistic model. Then after that, on the same data, we have created an LDA model, and on the same data where I was creating a QDA model, and probably all the other DF functions what we have learned, like we have learned QDA. After QDA we have also learned MDA.
Yes.
After MDA we have learned FDA, that is flexible, then RDA. So you can run various different models. How this phase separation is happening and how the discrimination of outcome is coming over there. So that we wanted to see.
Okay.
Next, is it sounding interesting? So we have 2 homeworks to complete. What are the 2 homeworks, people? Probably Mahindra we can tell. Mahindra, on project 4, what we are going to do, what we are going to complete?
Project 4, I think we need to build code for the QDA, FDA, MD, and RDA as well.
Yeah, that is the one thing you can do. But before that, some of the features we can drop and we can rerun the model.
Yes.
That is the one thing. Then that will give us a very clear understanding. Okay,
Yeah.
and then you can write a different discriminant model also. That is a task for the project 4.
Okay.
And now for what is the task for this small data? That is this default data. Default data sum of.
No, I'm not sure about this.
Okay, in the default data we have already written logistic model, but if you want to improve on that logistic model, you can do that. Okay, that is the one thing. Then I have also written an LDA model, so you can look into that. And I have just started writing the QDA model. So here also you can write various different model, and at the end you can compare the outcome of various different model. So in that case, what it will happen, not only within the various discriminant analysis techniques, we can also see a comparative findings between logistic regression and LDA, what you were asking at the beginning of the class.
Sure.
Makes sense, correct? It will be interesting task.
Okay.
So everybody is in for that?
Yes, sir.
Yes, sir.
Okay, so on that note, probably wish you a great week ahead. And apart from it, when you are also looking into the code for today or understanding from yesterday, have you gone through the class note I have shared yesterday? Any questions on that? Again, radio silence. Okay, so if you have any questions, please do ping me in our WhatsApp group, or you are free to reach out to me even personally. Only thing is, I want you to practice and to get a clarity of it. The LDA is a very useful and very good technique. It has got real world applications, and it will definitely add much more value. Not only LDA, I will say understanding of the discriminant analysis as a whole will help you much more, because going forward, based on various data, you see that not only LDA, various other discriminant analysis functions are going to be very, very useful for you. That's why I wanted to learn you all, means commonly used techniques, because there are much more complex techniques also, but commonly used techniques of discriminant analysis. Hope that makes sense, and
Yep.
wish all of you a great week ahead. Happy learning. Alok, I think we are good, so you can